Alright, so hopefully you guys played around in Desmos and started discovering what effect H is going to have on the graph. You guys are noticing that it's doing a very similar thing to what we've seen in previous chapters. So H is going to be that horizontal shift left or right. And this could be sine, cosine, or tangent. But a positive H, that's going to go kind of like opposite of what you would think. So plus pi over 4 would actually go left pi over 4. And then minus pi over 2 would go right pi over 2. So when I do these, I do them actually a little bit different. There's a couple ways to do them. You can still use your tables, and you can subtract pi over 4. You can add pi over 2 to all your x's. But a lot of students find that difficult, just because really it's adding fractions and subtracting fractions. So by all means you can do that, or I'm going to show you kind of another method for graphing these. So when I do this for A, I would start by graphing the parent. So we've got sine. I can put the points if you guys want. Just again your quadrantial angles. Sine starts at midline or 0. So we got 0, 1, 0, -1, 0. And I would scale this if I didn't have a graph already with just those 4 marks. I don't need the extra ones in between them, just so you guys know. And then what I'm going to do is I'm going to look at and think about, well, this function is going left pi over 4. So I'm going to think about how many marks do I have to move left. So 2 marks here is pi over 2. So half of that would be pi over 4. So I'm going to go left pi over 4, which is 1 mark left. So I'm just going to take all those points and just draw them one spot left on the graph. And then when I do this x minus pi over 2, that one is going to go right pi over 2. So I look at that graph and I'm going to see 2 tick marks would be pi over 2. So I'm going to move 2 marks right. So I'm just going to take that green graph, the parent, and go right 2. And connect my points. So whenever I shift horizontally, I always just count from kind of like the parent function. Or when we start putting stuff together, I would count from, kind of that initial like transformed function. Then I would just count it left or right. That's the only part I don't really do within the table. Again, just because adding or subtracting the fractions adds way more work to this than is necessary. Alright, so for B we've got cosine. So that parent graph of cosine there's our quadrantial angles. It starts at amplitude, so it'd be up at 1, 0, -1, 0, 1. And again, mind this scale. It's a little bit bigger than what I would normally use. I would just put those 4 marks as my scale. And then if you need halfway marks, add them based on your shift left or right. Alright, so this first one is cosine of x plus pi over 3. So it's going left pi over 3. So if I look at this scale, it's going by pi over 4. So this is going to go left, but it's going to go not an even amount of ticks. So I kind of have to think about where does pi over 3 land. So a third is bigger than a fourth. So this is going to be 1.5 tick marks, because a third is less than pi over 2. So it's somewhere right in the middle, or close enough for our purposes of estimating. So we've got, we're going to go left 1 and a little bit. Right, 1/3 is closer to 1/4 than it is 1/2, but just slightly. So I'm going 1.3. Again, and when you graph these, I'm not going to be able to tell if you want 1.5, 1.2. You know, just as long as it's 1 and a little bit, you're good. So this is going 1 and a little bit, 1 and a little, taking that point 1 and a little. This point's going 1 and a little. This point's going 1 and a little. Alright. And then this one, minus 2 pi over 3, that's going right 2 pi over 3. So again, I'm going to have to figure out, well, how far is this going? Right, so 2/3 is like, if you want to think it's fractions, like 0.6 repeating. Pi over 4 is our tick mark, so 1 mark is a fourth, 0.25. So 0.25 goes into 0.6 2 whole times with a little left over. So we're going to go right 2 and a little bit. Again, I'm not going to be super picky, because really, honestly, I won't be able to tell from your graphs if you went 2.5, 2.3, 2.5, 2.7. It all looks the same. So I'm just going to be happy if you understand how far roughly you're moving. And even if you have me again next year in pre-calc, you know, that's how I'm going to teach you to do it. Just understanding that it is just shifting right is the idea here. Alright, so I'm going to take that green graph, the parent, or the blue graph, sorry, the parent, and I'm going to go right 1, 2, and a little bit, 1, 2, and a little. Oh, I got 1, 2, and a little, 1, 2, a little, 1, 2, and a little. Then I'm going to connect, and we would be done. Tangent is going to be a little bit different. At tangent, again, I would start by graphing my parent. So asymptotes are at negative pi over 2, pi over 2. Y values are the negative 1, 0, 1. Oops. So there's our normal tangent. So then what I'm going to do is I'm going to look at these transformations. This one's going right pi over 2. And by right, I mean left, because it always goes opposite the sign, just like sine and cosine. So it's actually going left pi over 2. Always opposite the sign, just like every transformation you've seen before. And so I see that pi over 2 is every 2 marks. So what I'm going to do is I'm going to shift those asymptotes to left. And then those points to left. And this last one, minus pi over 4, is actually going right. Pi over 4. So that's what these are actually scaled by. Pi over 4 is 1 mark, so this is going to go right 1 mark. So I'm going to turn that blue asymptote right 1. These points right 1. Let's have that asymptote right 1. And that would be done. So what I want you guys to do is try out the examples on the next 3 slides, just to see, you know, hey, can you shift it left or right? You can put the parent on there too and then count from there. And then the next lesson is going to be where I'll kind of put it together, H and K shifting, and just graphing from scratch. Because sometimes with the graph already there, it's a little bit easier to see the scale. So I hope this helps. And again, if you guys have questions, please let me know. But this is the idea of the summary here. Right, H is going to be our phase shift, shifting horizontally, always going opposite, the sign.